We've got Brian Collada.
Hello.
Brian is here with a case study for us tonight. We got Chris Martino coming from the New York area. Is that right?
Yeah, New York area, sunny Long Island, New York.
Right, got the right corner of the world. We got Tommy Olivia from the Chicago area.
Hello, everyone.
Keith Perkins from
Oklahoma.
Thank you.
It doesn't matter.
All I could think of was Kansas. But
close enough.
Yeah, 1 out of 50. What can I say? And Chris Martino is with us tonight too. So hi, Chris, and of course Keith DeFazio. Good to see you, Keith, even though you're just a stone's throw away, I found out. And we have Jeff Miller, our technology manager in Durham, North Carolina. We got Rich Falco from Florida. Man, we're spread out tonight. I'm Randy Briggs from the CTI Research and Development Center in Raleigh, and welcome to Virtual Classroom. Tonight is a roundtable discussion revolving around diagnostics and good diagnostic process. We're going to have that discussion around 3 different vehicles with 3 different problems. And so as we search out the best path for diagnosis, please contribute in chat with any thoughts you have on what your path might be. Okay, who's ready to kick it off tonight?
I'm ready.
Okay.
Good evening, everybody. Today I have a 2012 Volkswagen Jetta case study. I'm going to share my screen real quick. That one. All right, you guys see that?
I can see it.
All right, cool. So yeah, 2012 Volkswagen Jetta. This is a 1.8 liter, so pretty base model Volkswagen. There's no flair to this one. Customer concern was she came in and told me that all of the lights are on. And I'm like, what do you mean all of the lights are on? And she tells me that all of the lights are on. I'm like, warning lights, exterior lights, what's going on? And she goes, all of the warning lights on the dash are on. I'm like, okay, that sounds interesting. So my service writer writes up the vehicle and gets the mileage. He confirms that all of the lights are truly on the instrument cluster, and hands over the ticket to me, and I begin to do diagnosis. When you're working on a Volkswagen, it's not common to see a check engine light. Pretty common. What do you think so, Chris?
Well, that's their native habitat with the check engine light on.
That's right. Yeah. So
you said all the lights on. I said yeah. So
that's generally how they run.
You know, if you ignore it, maybe it'll go away. I don't know.
Well, you see, Brian, that's how you can tell the battery works.
That's right. Battery is not dead.
Right. Not completely. Sure.
All right. Anyway, so moving on. First step here: verify the customer complaint. I get in the vehicle and there are no lights on. I start the vehicle, I move it around a little bit, there are no lights on at all. So I decide to take this car for a test drive just to see if any lights would come on during my initial test drive. And sure enough, within less than a mile, maybe 3/4 of a mile, all of these lights had come on. Not all of them, but all of these ones had come on. The ABS warning light, the traction control warning light, tire pressure warning light, and the airbag light all had come on all at the same time. So I pull the vehicle back into the shop and I do a pre-scan to scan all the modules for all the codes that are present. And I get a U1017 control module for ABS in the engine control module. And in the airbag control module, I have a function limitation seat occupied sensor due to implausible message. Now, I don't necessarily know what that means without doing some research. That's kind of a description that doesn't ring any bells for me. So I'm going to have to do some research on that. And in the ABS control module, there is a right rear ABS wheel speed sensor mechanical fault. Okay, that seems like a self-explanatory code. And then in the tire pressure monitoring control module, there is no signal communication sporadic code. Now, if you're Keith DeFazio, when you look up service information, you're cool, you're calm, you're collective. And then when you're me looking up Volkswagen service information, you begin to scream at the laptop because there's not much available.
Well, let's be fair. I mean, on the right, that's you in your normal state, Brian.
Well,
Oh.
yeah,
Lest anybody think this is you calm.
that could be, who knows?
Clearly there, I'm working on a Honda or something. Other than, go
I
ahead.
don't know. I
The
don't
hood
know.
louvers don't lie.
Yeah. All right, so in the engine control module, I researched the code that is present, the U1017 control module. I'm in all data, and I searched the 12265, and there's nothing found. I also looked in Mitchell, there was nothing found. I looked in Identifix, also nothing found. Okay, I have no diagnostic direction in the engine control module. So I moved on to looking up just the U1017 in Mitchell, or in Identifix, and also all data. And in all data, that code doesn't even exist in their list of possible U codes that are available. I'm like, all right. So I go to the airbag control module codes. I research them. Again, no information found, nothing found in all data, nothing found in Mitchell, nothing found in Identifix.
So in other words, Volkswagen situation normal.
Yeah, everything's normal here.
I'm seeing no problems here.
All right. Carry on.
Carrying on to the ABS control module, the code that I thought was fairly self-explanatory, there's also no information available, nothing. The no communication with tire pressure monitor code, also no information. So as of now, with my research that I've done, I have no diagnostic direction at all. Looking back at the list of codes, I had noticed that there are 3 potential codes that have, in my opinion, some type of communication issue within the description. The first one being a U code. There is, a U code by nature generally is a communication code. The TPMS code says no signal communication and function limitation due to implausible message that possibly can be a communication issue. So in the back of my head, I'm thinking possibly I have some type of communication loss. So I decided to just simply view data. Now I know I had a wheel speed sensor code, so I decided to view scan data for the wheel speed sensors while driving the vehicle to see if there's anything going on with that, just to see if I had communication with the ABS control module while I was driving, just to see what's going on. I began doing that, and then as I started traveling down the road, less than a mile, just like before, I got an error message on my scan tool. I happened to look down at my scan tool, and there was this error message. And I'm thinking to myself, okay, maybe that's possibly the communication loss. So I go ahead and I pull up scan data once more. I'm looking at scan data again for all 4 wheel speed sensors. That data is graphed, and I happen to notice that there is this downward dip in data. Okay. Shortly after that, I glance down back at my scan tool one more time, and I get that same error message. Now this happened once, twice, 3 times, multiple times in a row. Every single time that I would get that glitch in data, I would get this error message. So I'm thinking in the back of my head, possibly I have some type of communication problem, but I need to do some more research on that to figure that out. Once
Or
again,
you just stumbled on a Volkswagen in its native state again.
yeah, and a question came up before about potential when you're driving a vehicle. Sometimes when you hit a certain vehicle speed, the ABS will lose communication just by nature. It happens. That was not the case here, but that is something to consider in this type of scenario.
Well, what would be your proof that this isn't the case here?
Proof in that case is right here after the moment that this dip occurred, you can see that it continued on. So if that was the case where there was an error and then that caused a communication problem, you wouldn't see any additional data after the fault had happened. So that was my clue to continue potentially not looking at a communication problem.
Sweet.
Did it seem odd to you that the signal continued on and didn't drop like all the others did?
That's a good point. I didn't notice that until now.
What was your point? What was your point, Keith?
Notice that the left front, the right front, and the left rear,
Mm-hmm.
they seem to drop off completely, and the right rear did not. That's interesting.
Yeah, it was a little weird.
Anyway, so we'll continue on. Sometimes a scan tool will lose communication with the vehicle, and when that happens, you'll get multiple warning lights on a dash. Could I potentially have a faulty ABS unit? That's kind of what I'm thinking in the back of my head, but I want to be 100% on this one because I know if you replace this module with a factory brand new unit, that it would have to be unlocked with the factory OPUS scan tool.
Which kind of sucks.
But I do have friends like Chris Martino that can do it for me. And
It's good to have friends in low places, is what you're saying.
But anyways, so my point is, I mean, every time you replace a module, you want to be 100% that it's needed.
Mm-hmm.
But in this case, it's even more, there's more emphasis on it because of all the extra steps that need to be taken just to make that happen. Now, if you replace this module with a used unit, the control module no longer needs to be unlocked, and it can just be coded to the correct coding that the vehicle requires.
Now, question, because those modules, you mentioned that the new ones, it would have to be coded with the factory tool because the new ones have to be unlocked before you can code them. So generally, when I speak to people, I actually recommend used units for this particular reason, because you can code them all day long. How can you want to go with a used one just in case?
Eric has his hand raised.
Oh.
How do we
Okay.
want to address that?
Oh, his hand is raised. Eric, if you got a question, then what do we got? But yeah. So like, what would you do? Like, you could totally use a used ABS control module. In this
I
car.
could, but however, my shop, we typically do not replace control modules with a used unit. We try to get brand new modules so we don't have new issues to deal with later. You know, we like
Mhm.
to provide a warranty to the customer and all that. So used
So-
is not usually an option.
So you don't want to. Yeah. So you got to make 100% sure if you're gonna
Yeah,
spend the money
absolutely.
or you know, use OPUS or, you know, spend the time to have a program.
That's right.
Cool.
But before I could replace that controlled module or do the testing, I'm looking back at the list of codes I had, and the one that I mentioned earlier for the right rear wheel speed sensor seems to stand out to me. I have this gut feeling in the back of my head that I have some type of mechanical fault going on with that wheel speed sensor. And also, even if I had a communication problem, I would like to know if I had a wheel speed problem as well. I don't want to put a new module on this and restore a communication fault and then still have a wheel speed sensor to deal with after the fact. So I want to have the whole story before I, repair this vehicle.
Oh, where's the fun in that, man?
Yeah, no surprises at the end. So I'm a scope guy. I want to verify that this scan data is true. You know, is it truly dropping out, or is that just a result of a communication problem? So I wanted to scope the wheel speed sensor. So I go to the right rear wheel speed sensor, the one that's causing those random dropouts, and I see this pattern that I have on the screen, and you'll notice that I have this repetitive missing tooth here over and over and over, and it seems to be very consistent. I have a similar amount of teeth between each missing tooth, and I
Oh,
see
that looks like it's to line up the tire valve, so you know when you're done a full rotation.
That's top dead center of the wheel.
But usually you don't have a sync tooth in a wheel speed sensor. So in the back of my head, I'm thinking that's probably not right. But this is a Volkswagen, and they do things different sometimes. So how do I know if that's good or not? I would have to get a known good, right? So where do I get a known good for a wheel speed sensor on a 2012 Jetta? Do I call my friend? Do I look on ITN? Do I look on service information, which doesn't exist?
Matthew Potter answered us in the chat. Looks like you check on the other side of the car.
Yeah, absolutely. So I go to the left rear, and there's no missing tooth. I'm like, all right, cool.
That left rear must be broke.
Yeah, but here's the thing. How do you know? It is a Volkswagen. Maybe it is right or wrong.
That's a solid point.
Sorry, keep on going.
So what could cause a missing tooth on a wheel speed sensor? Is it the wheel speed sensor itself?
Bar fight.
Is there a disconnect issue, a wiring problem? What do you guys
Well,
think?
let's before we go on, let's talk about this signal. All right, what does this signal tell you?
I see a 12-volt bias,
Mhm.
meaning it's a magnetoresistive type sensor.
Mhm.
It's Hall effect. It's switching. It's not a variable reluctance sensor. So I see that it has 12 volts. I see that it has ground. So it's capable. The ABS control module is capable of providing that bias voltage to the wheel speed sensor. So it's not like the ABS control module is completely going dead at this. I see a lot of information here.
So yeah, exactly. This actually does tell you the whole story. I mean, there are some tiny leaps you may have to take for it, but the fact that the ABS module is capable of creating the voltage tells you that the wiring is intact.
Yeah.
I mean,
yeah.
so and the fact that the dropouts are perfect every single time.
And the funny part is the dropouts are so consistent here. It looks like it's one tire rotation. However,
Exactly.
when I'm driving the vehicle, it happens like every couple of minutes. I get a dropout, and then randomly I lose communication with my scan tool.
Yeah, but even to go a little further with that, like it tells you a lot more. So the fact that it's every single tire rotation, and if you put some curses in there, I can guarantee that it'll be exactly the thing.
Mhm.
I mean, yes, it could be a wire that was broken, and like a perfect metronome, every time that tire turned, it could be going off, but most likely it's not. It could be the module dropping out, and every time the tire turned, it dropped off, but most likely it's not.
No.
This whole story tells you everything. I mean, this tells you literally everything.
Yeah, I love it.
Yeah.
And so I'm thinking in the back of my head, I have some type of physical damage to the reluctor ring that's on the vehicle. Now I primarily work on domestic vehicles, domestics and Asians. That's what comes to my shop. And in the back of my head, I'm thinking of Ford Escapes. They have a steel ring that's pressed onto the nose of a CV axle. And in my area, I'm in Northeast Ohio, rust will develop underneath that ring, and it'll expand and crack. And
Well, you got to explain rust to Rich.
Yeah.
he doesn't understand that. Rust is what you get.
Wait a second. I'm not a Florida guy. From Jersey.
You're ruining it for everybody. You're ruining it for everybody.
I'm only ruining it for me.
You've been in Florida long enough. You've forgotten.
Quiet. Move on.
So yeah, in the back of my head, I'm thinking that there's some type of rust issue or broken part, something like that going on. So I need to look to see what's going on. And I'm looking in the wheel well to try to see a reluctor. I don't see one. So I'm doing some research. I ended up looking up the part for the right rear wheel bearing, and I noticed that the magnetic encoder ring is on the back of the bearing. Now this little strip right here, you can't see it, but if you have a little fancy tool like this, you can use to identify all of the little tiny magnets that are inside of there. This tool is kind of neat. I have one. It was given to me by a parts vendor, and I have it in my toolbox. I don't use it often, but if by chance you had some type of magnetic problem that you couldn't physically see, you could use this little window tool to identify it. One other trick you can do is putting a piece of paper on top of the bearing and then sprinkling some brake rotor dust on top of the paper, and you'll be able to also identify the little segments of magnets that are on the back of the bearing.
Awesome.
But this little tool is in my opinion, way better, way easier, and gives a much better visual on each one of the magnets. So I pull the bearing off. I get approval from the customer to remove the bearing. I told them that I need to remove this bearing. I suspected there's a wheel speed sensor problem, and I'm not 100% that there's not a communication problem, but I do know absolutely without a shadow of doubt that there is a wheel speed sensor problem. Let's try to identify that first. and then see if my communication problem is any better. So I do remove the wheel bearing. It's fairly easy on this vehicle. And I find that there's this tiny little chunk of something on the back of the magnet. Now it turns out that tiny little chunk happens to be a little piece of the rusted backing plate of the brake assembly for the drum brakes that have broken off and just happened to stick to the magnetic ring, which is awesome. So
Awesome.
I got this tiny little piece of metal on the bearing.
That's
Now,
a tiny little piece of Northeast Ohio.
it
That's
is.
what's on there.
It's an expensive tiny little piece of Ohio. This little piece of rust happened to cost about $700 to replace it. Now, talking to the customer, I told them I can probably just wipe the back of this bearing off, clean it up, put it back together, and then verify that I do or do not have a communication problem when I'm done. But the customer is a really good customer, and they said, "You have the bearing in your hand?" And I'm like, "Yes, it's in my hand." They said, "Just go ahead, put the new bearing on." And then, the car had about 100,000 miles on it, so they probably would need a bearing soon anyway. So he decided just to have me put a new bearing on it. I went ahead and I did that, cleared codes. I'm driving the vehicle, and there's no problem at all. All the warning lights are out. All of them.
All of them.
Every single one.
I find that hard to believe. It does not happen.
And the battery is fully charged.
Play the lotto. You found a unicorn.
So I'm, of course, driving the vehicle on the passenger seat. I got somebody else drive. I would never take a photo of a speedometer while driving. This is clearly not me doing that. Clearly.
Moving on.
And the car's fixed. So one little tiny piece of rust happened to cause a wheel speed sensor problem, and also caused all of these codes, which I was suspecting to be a communication problem. Now, if I was moving down the path of what I thought for communication, I could potentially be replacing an ABS unit that didn't need to be done, have an expensive ticket behind, have an expensive ticket for no reason, and still have a problem.
So I actually wanted to talk about this for a little bit, if you don't mind.
Sure.
No, I wanted to talk with you about it. So I deal with this multiple times a day, obviously, because this happens. And a lot of the people, like, you fix this efficiently with a scope, right? So you weren't swapping parts, you weren't doing anything. And I deal with a lot of people with this on the phone, and they get an exact code like this, and I tell them, "Do you have a scope?" And the answer is no. And I'm like, "Well, listen, if you go back to, can you go back to your waveform again? If you go, yeah, right there. I tell them, listen, if you have a scope, it literally tells you the entire story. They're like, "Well, I got a multimeter." I was like, "That's not going to help. If you spin it really slow, you might get a drop. You might get a drop up, maybe."
I highly doubt you'd see this.
Well, this is digital, so if you did spin it slowly, you will see it. You will see it go to zero for longer than other. But I mean, come on.
Yeah, but look at the total voltage amplitude from min to max.
Well, yeah, you would have to.
Is that half a volt?
Yeah, you'd have to play around some. So, generally, if you don't have a scope, how do you test this, like, without replacing parts? And what we end up telling people is, they've already replaced the sensor because you can't test it. So you've replaced no parts on this, and you know what the car is. You know what it is.
Yeah, there's no doubt in the back of my head at all that I needed some type of wheel speed sensor issue.
Yeah.
So let's tackle what's obvious first.
Exactly. So at this point, if you didn't have a scope, what would you be left with if you didn't want to replace parts? You're swapping stuff around. Okay, if you're over in Florida with Rich, that's not a big deal. This car will come apart. Generally in the Rust Belt in the Northeast, that bearing's not coming out with a fight, and it's not going back in. All right,
well, this happened to be a center spindle type bearing.
Okay,
it came right up.
Yeah. So what you would have to do this, if you didn't have a scope to check it out, you first would be swapping ABS sensors, right? See if the code moves. Driving the car. All right. Then you'd be bringing the car back in, and then okay, what would you do then? Well, then you'd be swapping bearings. All right. And if that didn't do it, say it wasn't this. Then you're swapping bearings if the code didn't move. Then you would be swapping harnesses left to right. All right, just to see if it was a module or something. If you just hook up a scope, just to the wheel, you figured out the problem.
Yeah.
Like it's
Yeah, even
that
just the
simple.
scope image tells you it's probably rotational, which means it's most likely the bearing,
Exactly.
Yep.
just of the frequency of the drop out.
And
Keith-
yeah, and knowing that there's no disconnects in that pattern, there's no drop to zero, there's no stuck at 12 volts. You know, it's a pretty repetitive pattern with a weird missing tooth. You know,
Yeah,
that tells a lot of the whole story just by seeing that.
Keith looked like he wanted to say something.
And this is the reason why you don't go to those classes that tell you not to scope.
Shots fired.
Scan data clearly did not help me that
I
much.
was wondering when I was going to get thrown under the bus.
I saw your smile. That's what drew it on. I'm sorry.
Scan data did lead you here.
No,
Drop
that,
out scan data.
that was going to
It
be
did.
my point. Scan data told you where to scope.
That's
Correct.
right.
Kind of.
But so we had a question on Monday when we ran this of efficiency while doing these kind of case studies. This is the most efficient way to check this car out.
I agree.
And a lot of people, they say, well, I don't have a scope. What do I do? Well, you can get a U-scope for how much, Keith?
$159 now.
All right. How many channels did you had to find that problem, Brian? One?
Just one to identify the bad one. I had to compare it to the other side, which I just could have moved my leads and
Exactly.
looked at it. I didn't have to have a 2-channel.
So $150. All right. What is your labor rate? What is your labor rate in the shop? Around $100. So a little over an hour and a half of labor. All right. How much time you wasting swapping parts around? That's what I try to explain to people. This is the most efficient way to do this. I'm sorry to hijack your case study, Brian. I had to get that out.
It's all great points, and I absolutely agree. That's all good stuff.
Even I can't argue with that.
Challenge accepted.
Well, no. Usually Brian's the one who starts the arguments, just for a reason.
No vortex here, not tonight.
So that was an awesome case study.
Any questions?
I think we're kind of good on the questions. People love that tool.
Yeah,
Hey,
it's a neat little tool that it was given to me by a vendor, and it's pretty cool. It's nice to be able to see more than one magnet at a time.
Yeah.
And it's just a great tool. Like I said, I don't use it that often, but in this case, it would have been helpful if there happened to be something I didn't see. If there wasn't a big chunk of something on the face of the magnet, it would have been less obvious. I would have to grab that tool.
I just put a link up to a Pico Series 2000 educational scope. It's a little 2-channel scope.
Mhm.
Fits in your pocket. A little lower voltage threshold than a regular automotive scope, but still a great little scope.
Mhm.
And right now on this vendor's site, it is $115.
Okay.
Really?
And I've got one, and they work great.
Yeah, that's the one I carry around with me teaching, and it works awesome.
Outstanding. I
So
want
Jim
one.
Morton in the chat.
I don't need one, but I want one.
So Jim Morton in the chat actually said something. He made a point. He said, you guys are hitting on a very important point. Without the lab scope and just depending on the scanner, I see a lot of techs going after the effect of the problem, not the root cause. And that's exactly what it is.
That's the greatest point about this is sometimes you have to take a step back and look at the whole picture. You know, is that, like you were saying, is that a tattletale code or is that the root cause?
Mhm.
And I was looking to me at which code had the most meat to it, or which one had the best explanation for me that made sense. I don't have service information to see what the other codes meant, so I decided to attack what I knew because I know how to test a wheel speed sensor. Let's go there first. It said mechanical fault, and sure enough, there was one. So
Okay, guys, Eric's put his hand up more than once. Eric, if you have a question, you can type it in chat.
I just texted him.
Okay, all right.
is he just messing around?
I
Well,
just
he's
turned
hands up.
Eric's mic on, so Eric.
I'm unmuted. There you go.
There we
Thanks,
go.
guys.
Eric,
Hey,
what's going on, man?
man, you know I'm a remedial typer. I can't. By the time I'm done typing it, I've already, that thought's long gone. Hey, I just wanted to point out that the graphing section that you were showing, that's pretty characteristic of that graph. It moves from right to left. So what you're watching is the start of the graph, and usually you have to get rid of that drop off, you just have to move the cursor over about a segment, and then it all evens out. So don't even just disregard that. That's your car's too late to drop out when taking off. So
Oh, cool.
that's all I had to say.
Okay.
Cool.
Thanks,
Appreciate
Eric.
that.
Thank you.
Thanks, Eric.
Yeah, anytime.
You know, on that note, how likely would it be to see that dropout if you're just looking at numbers? There's unfortunately
Yeah, that's
a
a
lot of
solid.
techs out there that aren't using graphing.
That's a
Well, that-
solid point because
that is a great
a
point.
lot of European scan tools do not allow you to graph.
Even the factory tool, yeah.
The factory tool does not allow you to graph, which is kind of interesting.
Why would you need that?
Yeah, especially
Yeah,
if it's a
read
moment,
code, replace part. Done.
which if you happen to choose the ABS code, I guess that would have worked.
Well, that test plan probably would have said, check voltage, ohm the wires, check the wire to the ABS control module.
Yeah, disconnect connector blank, and ohm each wire.
Yeah. and then replace the sensor. Oh, is that still the problem? Moving on. So yeah.
I wonder at which point in the test plan it says to check for dingleberry on the wheel bearing.
It's a brake booger. Brake booger.
Brake bugger.
Brian Gibbs says Drive Pro needs a graph button.
That was a Drive Pro.
Yeah, this is a Drive Pro, and to graph this, all I had to do was click on the numbers, and it became a graph.
Yeah, and if you actually slide your finger left to right on that thing, it'll become a big graph with like cursors and stuff.
Yep, full screen.
Yeah.
Yep.
I think I showed that on a BMW once.
Yeah.
So, all right, well, moving on. Who's next?
Me.
Who's
Hey,
me?
Tommy.
What up? So everybody, we have here a 2008 Mercedes C300. Well, give you a brief synopsis of this third-owned European vehicle. It was at three shops, and plus I think the owner was probably messing with it, or owner's boyfriend, whatever. I don't know. Well, initially came in looking for me, since I'm known for my particular area for having a decent amount of tooling and knowledge and a little bit of expertise in European cars. So they came in for the horns, wipers, and the turn signals were inoperative. I wasn't there when the car got dropped off at the shop. My one of my junior technicians, he took it in, and I figured it was a good vehicle for him to get his feet wet, kind of toss him to the wolves, see how it goes. Well, so first thing I told him was grab a scan tool, start doing some output tests. Bidirectional controls to the components were not working. Okay, well, after this point, I told him pull up a wiring diagram and let's see what components are being, what module powers these components. So as you can see here, the horns are being powered by the front SAM. Okay, so move on to the next component. And here goes the front SAM again, controlling our wiper motor. So last but not least, here goes our turn signals, and there you go. We have our control from the front SAM. I mean, at this point, with a common failure issue with these SAM modules on these Mercedes, and coupled with the fact that it's communicating, I instructed him to do a couple of tests, load testing, powers, grounds, check signals, etc. We mutually determined it needed a SAM module. And here it is. So just so you guys know, 2008 is a Zentry vehicle. So this module, when you install it, requires a login to Zentry and SE encoding. That's something that's on my vehicle. So once we got the SAM module in, which took about a week to get, I actually went to the shop and I programmed it, and all is well, right?
Well, let's stop you here.
Yes, sir.
All right, all right. So you guys, the junior guy, checked the powers and grounds, correct?
Mm-hmm.
And he checked the outputs, correct?
Correct.
And then he checked for outputs at the back of the SAM module.
Correct.
Okay, nothing was happening. Awesome. And so Like it seems like a pretty common issue, right?
I
Because you get that on
replaced
Fords, GMs.
I replaced numerous amount of SAM front and rear SAM modules on this range of Mercedes these years.
That's
Mhm.
like the European Chrysler Tipum.
Pretty much in a nutshell, yeah. So I mean, really didn't put a lot of thought into it, you know.
Seems on the outside seems like a pretty solid call, right?
Yeah, I mean, I was confident. If I had any other concerns and stuff, I would have probably went in and looked at it. But I was pretty confident in his diagnosis.
Okay.
Well, clearly the problem's right there in the picture. It's missing a couple of fuses.
Relays, fuses. Yeah.
That's true too.
No.
Well, so unfortunately, when after it was done coding and cleared the codes, and I went to verify the repair, and then unfortunately, it did not fix our problem.
Ruh-roh.
That's a big row.
It's expensive too.
That's an
Yeah.
expensive ruh-roh.
Expensive row, but you know, we're in the woods now. Let's figure this out. Now it's now this potential profit-making vehicle has become a lesson, some field day action. Anyway,
So the big boss has got to come down and figure this out.
yeah, the big boss, and I took the junior, and then I took the junior guy, grabbed him, and like, all right, me and you are gonna go over this car.
Eric had asked if the steering is turned all the way to the left or right, did the symptom change?
No.
No. Okay.
It did not. So here you go. Here's our he had most of my guys, including myself, have been trained to do pre-scans. Any vehicle, no matter what it is, any type of concern. And it doesn't matter if it's a freaking taillight in-op or whatever, a vehicle gets a pre-scan.
Always, yeah.
So I decided to start with that. Like I started with looking at the list, and as you can see, there's a lot of codes, most modules, typical third owner European vehicle, lack of maintenance or
A
whatever.
sea of red.
Yeah,
Correct.
typical third owner Chicago German car.
Yeah, you know, third
Bought at
owner
the auction.
European car, bought it at the auction, plus you know the rust belt corrosion.
Mhm.
It's really just not a great mix.
Almost
Oh.
as bad as the 5th owner 7 Series, but I'm sorry, didn't mean to interrupt.
Or the first owner Land Rover. Just saying.
Yeah.
Well, so you know, I just took a few minutes and started skimming through these.
It's just a
And-
sea of communication codes and nastiness, right?
Correct. That's what started. That's what really caught my attention. I'm like, wait, why is there com codes? But this thing also had a really weak battery. But this guy right here, if you look at number 8, this is the one that caught my attention. Communication with the central gateway. I was like,
But the air conditioning can't communicate with the central
I'm like,
gateway.
why can't it communicate with the central gateway? I'm like, what's the central gateway? What is this? I mean, I'm no Mercedes expert at all. I'm not an expert on anything. I just have proper service information, and if I can get the time, you can figure it out. And with networking, of course. Well, I decided, looking at a diagram, I actually decided my easiest way of getting to the CAN network was at the ME, which is the engine control module sitting on top of the engine compartment.
Mhm.
Took 2 minutes, and this is what we got. As you can see,
Yuck.
yeah, it's
So-
pretty bad.
Why did you want to check? Why did you want to check the ME? Is that's engine can?
Correct, engine
Okay.
can. I figured
It
I'd
needs a
take a
wheel
look at
speed
it,
sensor.
see how it looked.
Obviously, that's just another a brake hub.
Okay, well,
That right there.
my logic was, what's easier to get to? Where can I tap in? This vehicle, I assumed at this point it had various CAN networks, and I'm like, well, let's tap into this guy, see what's what. And of course, I saw this, and I was just like, okay, well, here's my problem. Now, if you go back and you look at page 1 of our diagnostic report, do you guys notice anything missing?
I see all body stuff in there. I actually no powertrain, anything.
Correct. Well, that's where I started really thinking. I'm like, wait, what's going on here? I
said
took the
this thing-
tool.
You said this thing starts and runs, though, right?
Yeah, it started and ran. That's why I wasn't like super
But you're
Paying
not
attention.
communicating with the engine control on.
correct. So once I actually started to communicate without an actual scan, because at the end of the day, it's still an aftermarket tool, I went in and every individual module by itself, and they were not communicating.
Now you said you used
And-
Sentry. Did you happen to scan this with Sentry? Was it kind of the same thing?
It was the same thing actually.
Okay.
Sentry was the same thing because after I used this one and I noticed that and I noticed it wouldn't go into the specific modules, I actually ended up grabbing my Sentry tool, went in, and it was the exact same thing.
Oh, you specifically went into the drive and stuff on the drivetrain.
Correct. And so what I noticed was the following modules: the ME, the engine control module, the ESP, the TCM, the SRS module, and the one that stuck out like a sore thumb was the steering column module. I'm like, well, so I
Yeah.
guess that's where our
But it runs.
commands are. It runs. I'm like, okay, well, now let's move forward.
Okay.
Now this started to make sense. Now, going forward, I decided to look at my AC circuit since that's the one that said it won't communicate with the gateway. Now, if you see, this is CAN B, and that's our AC control head. So follow that, and I found it underneath the driver's side.
So go
carpet.
go back one slide.
Yep.
All right. So the AC control you're saying is talking right to that CAN B. That's a connector, 3032 connector, correct?
Correct.
All right. Cool. And it lives right where?
It lives right here underneath that would be the driver's side underneath the carpet.
Oh, in the water.
Yeah.
Right where your foot would rest after you shake the snow off your boot.
Yeah.
Yeah, or a clogged sunroof drain. 'Cause, everybody cleans them out, of course.
Mm-hmm.
Well, all right, so did an inspection on that one. Didn't look bad. But I noticed something else while I was looking at these diagrams. I noticed if you look at our green and white wires, that's CAN E. Now,
How many cans are on this thing?
Like 6 million, right?
there's I believe it's about 6 cans.
Jeez. Okay. So six
Because
pack.
you need all of that to make the car start and run because reasons.
Well, it gets better. Over engineering gets quite better. But once you actually, go through the motions and stuff, it makes sense after the fact. But
So that
during the flight-
Mercedes needs a can to check the can that's checking the can.
Oh yeah,
That's,
because
That
these-
sounds- that sounds like Chicago politics.
moving on.
so that N101, what's that? The front SAM?
Yeah, that's correct.
Okay, cool.
Okay, so what I found interesting about this vehicle is kind of like Chrysler's Tipums. It's actually the gateway, so everything is routed to the front SAM, and when you hook up your tool to the DLC, it talks to the SAM, to the front SAM.
Mm-hmm.
And then it does the back and forth communication, and it starts reporting to the other modules, and it disperses the network.
Mm-hmm.
So I was like, okay, this is getting pretty interesting. I think at this point, we talked to Mr. DeFazio for like 3 hours. Because, what happened?
Yeah, it was up there. We spent some time on it for sure.
Yeah, we sure did, man. At that point, I was like, well, every single one of these modules that's on this CAN network was not talking, but the car was running. It ran, it shifted fine, other than the 3 issues that we were having with no wipers, no horns, and no turn signals.
Well, you could stop there. This is Chicago. Nobody uses any of that anyway.
Yeah, you don't need those.
Well, you need the horn.
Well,
Yeah,
when you're dodging bullets, you gotta stay.
Still need a horn.
You
Stealth
beat the
mode.
horn. You beat the horn when they're about to shoot you.
Still need a horn. But so X30.
The X3030 connector. I can see.
Correct.
I can see. Look, you're on CAN E, and it looks like it goes through that front SAM.
Correct.
Talk to the E ECM.
So another interesting tidbit about this particular module is that there's a couple of different networks that run through it. But right here, this is our ESP. This is our ESP9,
Okay.
and they all have one thing in common. What you got?
All right. So you got your ESP module, correct?
Correct.
All right. Cool. So that's on CAN E, and that is going to the X3030 connector. If you look up top. So okay. So that's going there. Let's go to the next slide. That's all your powertrain stuff. Go on, Keith.
Go back to that slide there for one more second.
Yeah.
So I noticed also there's that CAN E again. You have 2 CAN E's coming into that X3030 coming from the front SAM in the left-hand corner there, the N101. That's interesting.
Yep. That's you know, talking about it, you know, further, that was something that threw me and you both off.
Mhm.
Okay.
Yep.
So
Redundant.
God forbid they label them something besides E.
Yeah.
And we will get to that too. Here you go. There's X3030 again.
Okay.
So once you look at this, once you look at the diagram, you start seeing a common common theme here, and which is
Well, what I can see, go back. You see the X3030 connector, right? If you follow that, if you follow, can we? Hold on, let me see if I can. Let me see if I can draw. If I can annotate, I might be able to. I can. Hold on one second.
Uh-oh.
Oh, I can totally annotate here. So
That's
we're going
great.
to draw. All right, so check this out. You follow this up here, over here, down here. This is the front SAM. Oh, we're still going. We're still going all the way up here. Now, what is N3-10?
There we go.
All right, that's the ECM.
Yep.
Yeah, N3-10 is ECM on all.
Or if you speak Mercedes, ME, depending
Mercedes.
what, yeah, whatever you want to do.
Every Mercedes N3-10.
Correct.
N10-1's always front SAM.
So all of you Mercedes guys in the chat who are twitching when I say ECM, ME stands for motor electronics, and yeah, ME. So that's ECM for everybody else. But yeah, but you can see that it passes right through that front SAM to the ECM. So and everything seems to have that X3030 connector in common. Like all those diagrams seem to go there.
Well, let's go there.
Let's go there.
Well, going back to our foot underneath the carpet, it was right next to our Cam B connecting point.
Mhm.
So then I said, okay, well, let's take a look at this guy. Let's see how he's looking. And then look what we found.
Well,
Water.
yeah. Well, here let's go back a slide. All right, let's take a look at this real quick. So you have your where your arrow is. That's your X3030, and then you had another CAN bus we talked about before. I forget the exact number of that one. Another CAN splice, an X connector, or they would call it. But it looks like they're living upside down.
Correct.
And I'm sure because it's a fine German automobile and it's a very expensive when they came out fine German automobile. All those wires are sealed, right? They're
No.
the weather pack connectors and sealed,
Fortunately,
right?
they're not. There's
And
some little divots that are on the side of that plastic piece, and they just clip in right there.
all right, so we have the X30 and the X3032 connector. That's that other one, upside down in a channel where the water lives, because Mercedes had a great idea.
Well, at least they were easy to get to, per se.
So sorry. So let's go
Very
back.
good.
Let's go back to that campsite. So look at that.
Yeah, it was pretty rough. It was
So
pretty
now you
rough.
need a can opener.
Well, we popped it open, and look at that.
Oh,
Good Lord,
that's more than just a splice. What's going on there?
that is a mess. So I think Tommy Keith was talking about this thing, right? This is not just a normal connector.
Well, this one is actually also a terminating resistor, and the interesting part that we spent a few hours on is that we really didn't know. After looking at the diagram and experimenting, I kind of assumed this was kind of sort of maybe a fancier version of like a star connector. I figured I'll try jumping the network, see if it comes back. But actuality, there's two networks that runs through here, and this little guy will disperse it. So I was actually shorting the two networks together.
Awesome.
Two networks, one splice. Awesome.
That's just awesome. So, and I think because we were talking about this a little while ago. Yeah, you're right. They're all two networks, and the ins and the outs and stuff. They're not right next to one another, right? It's kind of
they are. The only one that's different is the front one. And that one comes straight from the front SAM. The number 2 position also comes from the SAM, but the other 4 of them, 4 or 5 that are there, you anytime you mess with this particular connector, you have to make sure I would actually just
let's say you go back over to that other diagram again where we had where we showed that one.
Which one, Keith?
One more, I believe. That one there.
This one?
Yeah, this one right here.
Okay.
So if you look at that one and you look at your N10-1 and then you look at your splice up top, let's say you decided that you were going to have the front SAM going into that splice pack, and you did not connect number 2, but you had number 1 and number 3 at the top at the X3030 together. You would not communicate to that N30-4, would you?
Correct, and that's exactly what happened, and that's how we figured out that it was actually 2 networks.
That's right. Yep.
Because
So
reasons.
even though it looks like it would, it's not the same, right? So there is one there for the ground for the terminating resistor that's there, and then as you see here, this number 2 is also another communication network there that's going to communicate to number 3, number 4, and so on.
Now
Right?
let's talk about this a little bit more too.
There for termination resistance.
Let's break this down a little bit more, because right now we're using. If any of you have ever used looked at Mercedes factory diagrams and like all data or Identifix everything, they look nothing like this. All right, you get those white diagrams with a bunch of words on them and make 0 sense, and good luck finding any information.
Definitely.
Yeah, and you guys were on like aftermarket diagrams and stuff like that, correct?
Both actually. I just
right.
couldn't really make,
So like
much sense.
there are times when a diagram like this helps break everything down. Go back, go forward one, Tommy, right here. All right, this diagram right here. If you by the N10-1, all right, this diagram right here is really not available in an aftermarket diagram. The fact that you could see that the communication path for the ME goes right through the SAM. You don't know that. The only way you'd find it is this specific diagram on OE information.
I do like how pretty that diagram is, by the way. The colors
Yeah.
jump out.
It's definitely a nicer one.
Mhm.
Most of the factory CAN networking diagrams are decent, except for a Volvo.
The interactivity with this, being able to click and hot links and bringing you to pictures is impressive too. Yeah.
Yeah. So this is one of those situations where having access to OE level information it just makes the diagnostic so much easier, because we looked at this particular diagram after the fact, and I was like, oh wow, this is like super simple. But yeah, sorry guys, I didn't mean to interject.
I love this one.
This is a good one. This was fun. So, all in all, we learned a couple things. I learned that this component is actually pretty inexpensive, and that the parts guy didn't know exactly what I was looking for, so he just brought me a bunch of them.
Awesome. So let's talk about lessons. You brought that up. Let's talk about lessons. All right. This is obviously a teaching moment for you guys at the shop, right?
Oh yeah.
So obviously your guy made the wrong call, but if you think about it, if you're just working on everything, all right, you can't. If you're working on everything, you can't be an expert on everything. And it seems logical. Your call seemed logical, right? If you're working on if this was a Dodge minivan, and everything happened the way this happened, you'd call a tip-em every day, and you'd be right 98% of the time.
Definitely. I mean,
hell, even on this, you'd probably be right. 70% of the time.
Yeah.
Eric asked if we measured resistance of CAN at any point. Which CAN, I don't know, but
No, I did not. I just scoped it.
And where would you test it from would be the question.
yeah.
Do we have a gateway module, right?
Yeah. So yeah, you got your diagnostic CAN, right? Your DCAN, I guess they would call that, or something like that. But that would be, you would have your 60 ohms there because you're just talking to something. So yeah, if you measure it at 6 and 14 at the DLC, it's going to come out fine, right?
Yep.
Yeah.
Yeah. So then you got to figure out how your CAN is split up, and unfortunately, like service information, aftermarket wise, is tough unless you kind of know how it works. So at this point, you'd really need to, be an expert in this, or at least know an expert to kind of lead you in the right direction, or at least do a lot of research. But you guys learned a lesson though, right? Like, it's like, what did you guys learn from this exactly?
I think the biggest one is just to take a few minutes and actually go through your pre-scan and look and just get a better idea of what's going on. Pretty much like Mr. Morton says, know your enemy.
Mm-hmm.
And use all the information available to you to attack your enemy. And this was actually one. It's a good lesson because it probably won't happen again. It's an expensive one, but it was definitely worth it.
I'd like to say that there are some tools that will tell you at the bottom of your pre-scan of all the modules that weren't there or did not communicate at all. So that may have been helpful if you happen to see that at the end that, if you see
No, for sure.
if you see engine control module not communicating, there's a problem there.
Yeah,
Now,
definitely.
the tool that you had there didn't do that, but some tools do.
Yep.
Yeah, and I see that too. I mean, usually a lot of tools do that, but there are some that doesn't. But yeah, like I know you guys got you have his entry. It'd probably have. I don't know if that'd have it there, but your Autologic would do it. I think you got a launch too, Tommy. That would do it too.
The launch for sure. I had it with me. That was actually when we got the vehicle in, because remember I have most of my good stuff is on the truck with me. That's the tool I leave back at the shop.
Yeah, so something like that, where at the bottom of the scan tool, if you get a good tool, because I know for a fact you got 2 Autologics. If you would have used that, you would have done a vehicle scan on that. At the bottom, it would have said, yeah, modules not fitted or not communicating, and that is, a lot of people overlook that, but that's actually a big thing, especially if you're looking at a Mercedes. I use that mostly a lot for Mercedes and Land Rover, and because that's a big hit right there. So, that would definitely help with your process, but stand back. Take a step back and just go over what you got in front of you.
I definitely agree. I mean, it's always, using the tooling you have to your advantage.
Awesome. That's pretty awesome.
I think
All
that's
right.
it
Yeah,
for me.
I think that's you. All right, cool.
Nobody asks me what I learned.
Keith,
What did you learn?
I
what
learned
did you learn?
not to answer my phone after 8 p.m. when Tommy's calling you on a weekend.
You call them at 8 p.m. I mean, this guy likes to sleep. He is barely up. He's late to rise, early to bed. That's Keith.
Yeah.
Well, we've got one more left, so I've got mine. So if anyone's still hanging out in here, a couple people still watching. This will be super exciting. This will be an exhilarating case study. Exhilarating. So this particular Honda Pilot, the tailgate, and I will start by saying that I'm going to call it a tailgate, not because I'm in Oklahoma, but because the service information designates this as the tailgate assembly. So basically the back hatch.
They lie.
Yeah, I don't know why. Just that's how they do it. So the tailgate does not open, but the glass itself will open by pressing the button on the key or by pressing the glass pop on the driver's inside of the driver's door. So there's a button that looks like it should open the entire tailgate assembly. It actually is designed to just open the glass, and it did take some time to figure that out. So there's a lot of learning experiences on this car. I don't often have to diagnose tailgate issues on these, but you'll see why this became what it became. So what was interesting, on the outside of the tailgate, there was the button number 1, which is designated here inside the handle. That should open the entire tailgate assembly, and then button number 2 on the side there should have popped just the glass. Now, neither of those would function at all. But remember, the glass would work by using the key or the one inside the door, the driver's side door. So those are kind of things to take into mind as we start to build our reasoning of why this is the way it is. What do we got here? Sorry, trying to keep up with the chat at the same time. So, this vehicle is currently at a collision center. So that's our first we should think about. The front bumper and both passenger side doors have been repaired. The O2 sensor wiring was repaired under the vehicle. There was a repair to an exhaust hanger. And those were all the repairs that were noted to me. Now, apparently they hit a wheelbarrow while driving on the highway. So it was a relatively involved
Because Oklahoma?
repair because Oklahoma. Yeah, wheelbarrows just all over the roads.
just dodge them. Just
They're
dodge
everywhere. Yeah. So the customer states the tailgate system worked before the collision and the repair. So we got to keep that in mind anytime we're talking about a post-collision repair. It is possible it has nothing to do with the repair. And that may or may not be there to throw you off. So do we check for codes first? Where do we start? What are your guys' feelings? What do you start with on something like this?
Gallon of gas in a match.
Yeah.
I'd pull codes.
Pull codes?
Sure.
Got a visual inspection? Would you do a visual inspection before you pull codes?
Probably.
Okay.
Yeah, maybe. I don't know. Both?
We maybe look up how it works too. All the same. Is this all part of one maybe research step?
I would call that step one, all three of those.
Yep. So that's kind of my thing too. I want to pull all the codes first for two things. One, like Tommy said earlier, I want a pre-scan. I want to know what was there before I touched it. So, the customer Everett sends you, I don't know if you guys have the same customer as I do, but Everett sends you, comes around every once in a while and blames anything on me that could have been there before.
Well, I have a lot of Italians by me. It's a lot of Funzlos.
Okay.
Moving on.
Yeah, moving on. Yeah, I'll leave that one there. So also, how does it work? Those are all kind of things that I would look at. So we went ahead and pulled a report, again, with an aftermarket scan tool like Tommy was showing earlier. We only had 3 codes. We had a modulator control unit power source circuit, ignition circuit, low voltage. So we started thinking, okay, we had a low voltage code, but that's in the ABS, probably not related. We had a body electrical system, a problem in the driver's blower motor circuit. Very descriptive. A problem.
Brian Gibbs had mentioned pre-collision repair pictures would be helpful as well.
Ah, that would be helpful. Wait for the next slide.
Ooh.
And then a code in the air conditioning system, which is also a problem in the driver. I don't know if it's B problem and C problem. I don't know how many problems there can be in a driver's blower motor circuit, but those are all there. Small little note, although they say current codes, they all cleared and went away and didn't come back.
If it's a German car, you can have about 12 problems in a blower motor circuit, and they could be all
Yes.
different.
Yes. So that was our report. Nothing that stuck out to me that said, hey, we have a problem with this liftgate. Now, this is not a power liftgate vehicle also, and you'll see later on as we get into that. So they had already pulled the back hatch interior panel off to inspect. And then this is where it got a little fuzzy for me as well. So I started looking at this and I took these pictures because I like to take pictures of it. And I do like to inspect the pictures they take before they do any repair either. So I did look at them to see the extent of the damage. And it was not very much damage on this vehicle at all. So if we look at these a lot closer, I could see there that there's a point where it looks like a very bulky piece of material underneath this electrical tape kind of ran right into some duct tape.
Yeah.
Yeah, that it doesn't look factory to me. I mean, yeah, the clip's there. Brian, I think you pointed out that the clip was there when you saw this picture first. I undid that clip with a pick, so, I mean, it could easily be done. Then the electrical tape molding with the duct tape there, those were all kind of things that stuck out in my mind. This didn't seem wrapped very well.
That shiny black tape doesn't look factory either.
No, it does not, and it seems to be coming off right here.
Yeah.
Then there seemed to be a whole lot of wiring extra. There's some, I don't know if you can see the looping that's in there.
Yeah.
It did not look like a nice OE harness. So these are all things that, the rest of that harness looked okay. Like this up here looks all right. It looks pretty factory with the twisting and everything. I would like to have seen loom, but it's Honda. It's possible I didn't. But the duct tape is what had me going. It looked like duct tape. It's kind of interesting.
Well, that little harness looks like it was made in Cold War Russia.
Yes. Yeah. So taking that into mind, I started immediately thinking, all right, we probably have some ingenuity that's happened in here that may not be the best of quality. And someone may have been in there before. So maybe it didn't work before the collision. So these are all things, this is a visual inspection we're doing. We're taking this all in at the same time. So then I want to know, how does this thing work? And usually for me, I could go read a description of operation, but if you guys are like I am, you might have to read it 3 or 4 times to really grasp what's going on. And then if you apply the description of operation to a diagram, you may get a little more information. So you can see we have this under dash fuse relay box up here at the top. Inside of that is a multi-controller internal control unit, multi-processor internal control unit thing, MICU. That has an internal tailgate unlock relay. That appears by the diagram to be just a power output. The relay is commanded at some point in time, closes the circuit, applies power to this tailgate release actuator motor, which is constantly grounded at a G601 on the other side. Internal to that latch assembly, there's also a position switch. And then external, this is the button that we have on the outside that was labeled number 1 earlier, the tailgate outer switch handle pressed. And then we have a tailgate latch switch release actuator diode in the circuit as well. So that's kind of, looking at this, it seems pretty straightforward. It's monitoring the position of the actuator, There's a command here from the tailgate switch, which is also a constant ground. And then the rest of that's just a power and ground to a motor.
It's like
So
a
it seemed-
super simple circuit.
Right.
Seems
I mean,
simple to me.
this is simple. This is not rocket surgery.
So it needs a module.
Right. So we go, all right, on a customer command type issue, on something that does that, how I approach these is checking IPOs, inputs, programming, output. That's how it works. So we have an input, which would be a switch, programming inside of a module, now entering the matrix. And then we have an output control. We have this hatch opening on this Volkswagen, which is identical to the Honda, obviously.
Yeah, well, it's the same thing, except
It's very difficult
except
to find
that will be the only time that rear lid opens. Just letting you know.
yeah.
Actually, no, that one's a Chrysler, so that's why it works.
Yeah, well, it's pulled up by a string. That's why, and I will also reference that this is a GIF, so it's one of those things that.
That's a weird looking GIF.
So, I like to check other scan data, right? Because if it's inputs, programmings, and outputs, almost all of that stuff can be seen from scan data. So what we do is we take our scan tool, we throw it in the trash, and we get a scope. I'm kidding. Rich is over there itching real bad.
Scope all of the things.
As much as I
Easy
love
there, Hans.
scoping
Hans is
all of the
watching.
things. Yeah, I love scoping all of the things. Absolutely.
That was
This
mine
particular
first.
diagnosis does pretty much rely on scan data for the most part. So we're gonna look at this. If we look at our scan data, this is some of our data PIDs. There's a trunk lid tailgate switch here, and these are the same data PIDs twice when I'm pressing the button on the back. So that button that did not operate the tailgate assembly, we're pressing it, and we're seeing an input. And this goes straight to the fuse box assembly with an internal MICU. So at least we know the circuit for, and if we go back, the circuit from this ground right here through this tailgate handle switch, I apologize, over here to the side, all the way back to the MICU is a good circuit. So we can also infer that probably this ground right here is probably good. Again, probably, because there's showing multiple splices here. So there's a probability of other issues. But at least from this point to here is good. We can know that.
Or there's a screw in the wire, and at least the screw is grounding it.
Right. God, I wish I had that picture right now. So if that's the case, we have no output control, right? So we're seeing an input and we're not getting any output control. Because if you look up here right above this trunk lid release command says off. Even when depressing it on, it's deciding I don't want to do this for some reason. Something's up. Whatever is controlling this or whatever inputs are bust across from one module to another, and there's all kinds of probabilities here. Whatever's happening, it's not happy, and it doesn't want to actually command the release. So if there's no output control and we're not seeing that, should we check to see the system's ability to work? Should we spend the time, even though we know the module's not attempting to power probe this release motor, or should we check and power and ground to and from the actuator source?
With a power probe.
With a power probe, specifically. Should we check the controls to the actuator? So why would we do this, or why would we not? I think the consensus is probably the same for everybody on the panel here. We probably would do this, right? Anybody that wouldn't?
I just work on German cars, man. You can't ask me this.
Right. Because the devil's advocate for this is, well, the module isn't even trying, so who cares?
Mm-hmm.
Right? And that's a plausible thought process. And I believe me and Brian once had an issue where he was seeing very similar data output for starter control
Brian
on
and
Mercedes. That's right. Yeah, Brian and I apologize. Some Oklahoma slipped out there.
I come first.
Yes, Brian and I, we had a vehicle we were talking about that was a starter control on a Mercedes, and it actually ended up being that the module that was commanding this saw that there was an error on the other side of the circuit and stopped commanding before it could even change the data PID. This was milliseconds of time, if that, maybe even less. It was enough that a voltmeter couldn't pick it up. We actually had to use an oscilloscope to see a quick engagement attempt by the starter and then immediately going, no, there's something wrong.
So if the circuit was affected, like an open actuator or open wiring or
a shorted actuator.
Shorted, yeah, sure.
Right, maybe the MICU is trying to protect that motor. It's a motor with windings.
Maybe the latch got damaged in the accident and is shorted somehow, or who knows?
Who knows? Exactly. Who knows? Wiring goes all over this thing. Obviously, it goes to the front of the car and the back of the car because this fuse box is under the dash. So there's a couple reasons why we would want to check that, but those are a couple of things to take into mind into thought during this. When you're considering what you're going to do, I would attempt to see if that would work. And the answer to that is I was able to perform a bidirectional actuator test and open the tailgate assembly. It worked flawlessly. It would open every single time with bidirectional control. So now, again, going back to our diagram, we know that this MICU has the ability to close this relay and provide power, and that this ground is good. So really, we don't have to check any wire. We don't have to get the scope out at this point currently.
It's all in the scan tool.
Right, still all in the scan tool. We've proved that all of these grounds are good, that this relay functions, that this power source from C, we don't have to go tracking down another diagram. All of this functions like it should.
Before we go, question from the chat. What's an MICU?
A microprocessor internal control unit. It's a little bitty computer inside of a fuse box.
Okay.
It does wizardry inside of it.
It's Honda's version of the TIPM.
Yeah,
It's like
yes.
it's like a SAM.
It's Honda's version of a TIM. Yeah.
So it's
There's a
wet.
trend here.
So it's run on Elfin Magic is what it is.
Correct.
Okay.
So inputs work, outputs work. So all that's left is programming, right? So
Oh, yeah.
what do? Do we update the BCM program? Do we update the programming? Should we
Program all of the things.
logic locked? Right. Or do we just replace it because it's a Honda and there's no update for a fuse box?
Well, if you go and read the bottom of every single Honda test plan, what does it say?
Replace with known good part.
There you go. Just jump to
Right.
the end.
We
That's
got no
how
codes.
diagnostics are done.
We have no codes to work with, right? We have inputs and outputs work. So obviously the programming inside's messed up. So we would just replace the MICU. Well, I have a hard time doing that because I've never called for one in my entire career. And everyone I called and talked to all said, I've never replaced a fuse box on a Honda. At least not that. Not for that.
Unless it was physically damaged.
Right. So we got to start thinking, what does it take to make this thing happy? What does this MICU need in order to perform this output function? There's got to be something we're missing, or we just really need a BCM. So can we have this issue without any DTCs or illuminated lights? Obviously, we're having it. And my thought process is, all right, let's dive real deep into service information, because everyone knows I like to dive real deep into service info.
Oh yeah, you're a big nerd. Another
Yes.
question in the chat: is there a hotel setting or a speed input issue?
Valet mode, yeah.
Yeah.
Right. I actually contacted Brian. I think, oh no, it was after I fixed the car. We all talked about
Yeah.
this. Some vehicles do have a switch that disables the ability for that to work. This vehicle does not have that. It's nowhere in the wiring diagram. It's nowhere in the owner's manual, and it is not existent on this particular vehicle.
Well, it's just hidden. It's hidden.
Maybe other 15 pilots have it, but this one did not.
Okay.
So
this one did not have a power liftgate, right?
no power lift gate.
Yeah,
This is
maybe the-
simply a
Maybe the
release
model,
actuator.
the models that have a power liftgate may have a switch. you know.
Right. No telling. So on initial inspection of service info, this kind of, there wasn't really much information on this. When you go to description of operation of it and you find it, it just says that the MICU applies power to the motor is constantly grounded, and it's released. So it doesn't really give you much information. I had to really go pretty far. I actually had to call a friend to get information and said, hey, have you seen this before? What's the deal? So he gave me a couple little quick silver bullet checks. I hate to say that, but I mean, he said, all right, lock the door with the key, hit the button twice. Does it honk? Yes. He said, all right, all of your actuators are plugged in. He said, this can happen if an actuator gets left undone. Because what happens is that the MICU is looking for a lot of inputs, and there's something that's not right. He said, usually we see an actuator unplugged. I said, okay, so it could be any of the inputs to the MICU. He goes, yeah, we've had it for all kinds of crazy stuff. And I guess, I don't think I said his name last time. It was Chris Roberts. He's a Honda dealer tech, a very experienced Honda dealer tech that's very intelligent.
Oh, Chris RoboCop.
Yeah, Chris RoboCop.
Awesome.
Yeah.
Good dude.
Guy.
Works for Hendrix, right?
Yes.
He's the Honda guru.
Yeah. I believe he's won the Randy Dorton Engine Building Challenge a couple of years as well.
Smart dude. Get to know this guy. Find him on Facebook. Friend request him. Blow his Facebook up.
Yes. So he basically said, man, you're going to have to look through every single data pin and just see what doesn't stick out. And I got there and I did that, but scouring through this service information a little farther, this is almost after the fact that I found this. I found the description of operation of the MICU, not of the tailgate actuator.
And where did you find this information?
This is an excerpt directly from Autologic.
Okay.
But it is available in, I believe, Identifix and for sure the OE.
Okay.
I found it first in OE, and then the excerpt I use for the class is out of Autologic. Because I usually I'm at body shops, I'm using OE service information. The subscription is $30. So it's not a big deal. So I found this, that the tailgate outer switch operation, the MICU controls the tailgate release actuator based on inputs from each switch. And it lists all the inputs here, both from the MICU directly and stuff that's bused to the MICU from other modules. And then if those are all happy, you get an output of the tailgate release actuator. So we now know that it needs to be in park. The tailgate outer handle switch has to engage. We know that one's good. We saw that in scan data. And interestingly enough, the left rear door and the right rear door lock knob switch unlock position has to be happy. And I don't know what that is, but I can tell you that left rear door lock knob switch unlock is the state of unlock of that door. So it is either on or off. So if the data PID says on, it is unlocked. If it says off, it is locked.
Because reasons.
Because reasons.
That's not confusing at all.
Over the beacon, where you see it says driver's door lock knob switch lock/unlock, that's 2 data PIDs. Either one can be on or off. So there's 2 data PIDs, a driver's door lock knob switch lock and a driver's door lock switch unlock.
Don't ever tell me German service information doesn't make sense, because this is stupid.
Yes, it is. Because reasons. But it wants to see a plausibility. Can you have both of them on at the same time? Can you have lock and unlock on at the same time?
Sure.
Not normally. Not normally. So you would be able to see that. But anyways, I still don't see why you can't just have one and work.
Depends how fast your finger is.
Right. So those two are actually wired directly to the MICU, the ones that are BCAN, but there still wants to see it over BCAN. Again, there's so much logic going on here. So those are all the data PIDs we need to see.
All of the logic.
So here is a data PID list, and you can see on the left-hand side, we see the driver's rear door lock knob switch unlock is on, which means it is unlocked. And then we see that the passenger's rear door lock knob switch unlock is off while we're pressing the tailgate switch, which means that the passenger's rear door is locked and the driver's rear door is unlocked. So immediately, that's what jumped out to me. I saw all the rest of the doors were unlocked except for this passenger rear door lock knob switch. So we went kind of to the circuit diagram of that, and we can see again, there is really simply just a control or a ground that goes to the switch. If the switch is in the 1 position, it is sending a ground to the MICU to indicate the lock position. What was kind of interesting, if you look at this, there's 3 connectors here. And kind of inspecting this wiring diagram of how are these all working. I didn't bring them all up, but these 14-2 and all the rest of these diagrams kind of all loop together. And there really wasn't a way that this could be a loss of ground unless it was this 782 connector. And if you see 782 right here, pin 7, but if you look right above that, 782 pin 6. So this looped to allow this to happen. This 782 is the power window switch connector. So if this switch is in this, if this connector is in this state here, the unplugged state, there is no ground to the right rear door lock knob switch. But all the rest of the wires in this door lock actuator knob switch, which is for the actuator and for the door opener close position, is all working. So if this window switch, this goes straight up to the window switch, is unplugged, you would get a position where all the actuators work. Everything works except for the window, who checks the right rear window for a tailgate problem.
Do you know
And this is actually a picture of the vehicle. I pulled this panel loose and took this picture by sticking my phone down there and saw that this was unhooked. Inspecting the diagram, I said, all right, I need to go to this connector. Where is this connector at? Honda service information gives you pictures with arrows.
Do you know if all those connectors are in a rewritten diagram, possibly?
Yeah, Keith brings up a good point that an aftermarket wiring diagram might have just edited out that detail just to simplify it.
Yeah,
So
I come across that all the time.
anyone
yeah.
that knows me knows I abhorrently hate aftermarket wiring diagrams. And I understand that there is some ease of use with an aftermarket diagram in a lot of circumstances. But you have to also understand that there is a reason this diagram was written the way it was. And it makes it so much easier if you just learn each manufacturer's diagram. And not to go too far off to the left, but basically, if you have a communication fault on a GM, like let's say you can't talk to the engine control module, the factory wiring diagram, you can select the module and it'll show you all the powers, grounds, and serial data lines that go to it that matter to talk in one diagram. All the aftermarket diagrams do not do that. They show you all the wires that goes to this module, and that's a lot of work.
Stop teasing us, man.
I'm just saying. I'm just saying. That's how it is.
Great.
So the summary is, have a process, follow process. If that doesn't work, phone a friend. But something about all the answers are not found in service information brings up. Earlier, I said, should we drain the capacitors and see if this module's in logic lock? I did that, and it led me astray for 30 minutes. When I drained the capacitors on this car, when I undid both battery cables and touched the two battery cables together to do a hard reset, this tailgate worked.
What?
Like 40 times in a row.
But wait a second, Keith. Didn't that operation thing clearly say that all those switches and locks and the lock unlock lock and the lock unlock lock have to be in the correct position?
So let's say, is it possible that one door lock could be unlocked or could be locked while the other ones are unlocked? Just in a normal circumstance, could I reach back there and press that lock knob switch?
Can we say lock more times?
Yeah, lock. So under normal circumstances, could I reach back there and lock that one door? Right? So obviously that would prevent the tailgate from working, you would think, but it doesn't.
And what if you did that logic lock reset and then it worked and then you left?
Then you shipped it. You said, hey, I fixed it. It was logic locked. You
So
owe
hold
me
on.
X dollars and I leave.
We need to stop here because Keith brought up an interesting question. He posed it to the chat and it wasn't answered. What is logic lock?
Right.
What is it?
That is where you have a certain amount of errors or some event causes a module to stop doing something for no reason other than reasons.
I call it stuck on stupid.
Right.
You're in that moment where you're in diagnostics and you just stuck. Sometimes you got to walk away.
It's the point where you have to turn it off and turn it back on again.
So
that's
where I was
logic
going was that the module was not in logic lock.
Like Steven said, a computer brain freeze.
Exactly.
That's a
This
good one.
actually was not the case. All I had to do was press the lock and unlock button on the key a couple times for the MICU to recognize that I commanded lock position on all doors, but one door did not, or I commanded unlock position on all the doors, and one door did not unlock. After that happened 3 times, tailgate stopped working.
But it did not set a code.
Never set a code. No, it just
Awesome.
noticed a position was wrong.
So here's the weird thing, right? All right, so all those data pins that were required to be able to open the tailgate, I can only assume for Honda is for safety reasons. They want to make sure everything is safe. So some engineer decided that we can kill the children 3 times, but that 4th time, no, we got to be cool.
This tailgate will not work anymore. Only from external. We can still open it from the inside of the car.
It's almost like they wanted to process the logic to create a code, but they didn't complete that.
Yeah, they ran out of numbers.
It's like, maybe not.
Yeah, who's really going to run into this? So anyone that's kind of, maybe it's a little fuzzy on that, just what happened was, once you undid that, once we drained the capacitors and told the MICU to forget all of what it's learned, it would work over and over again. And I did this process 3 or 4 times after I found this. I would drain the capacitors, put the cables back on, open the hatch 5-10 times, and then press lock unlock a couple times. And I found that it's 3 times. That's what it takes. So basically, once it saw that there was definitely an error with the lock position of one of the doors, it said, all right, we're not going to open this tailgate anymore because maybe we can't trust that the door is opened or closed or locked or unlocked or what. Maybe it's not safe to open the door.
You got to get Chris RoboCop to enter that into the service information because he can do that.
He is on the Super Tech team.
Yeah.
So you phoned a friend.
Mm-hmm.
Tommy phoned a friend.
Mm-hmm.
Mm-hmm.
Brian?
I messaged a friend.
Brian doesn't
He's
talk
kind
on
of
the phone, by the way.
antisocial. Yeah.
So yeah, you brought that up, Keith. We have it seems like a common theme.
What, networking?
Ooh, let's talk.
Maybe understanding that you can't know everything.
Yeah.
And we got
Yeah,
DeFazio here, and he's saying that you need help sometimes. That's a big
Absolutely.
deal.
So I mean, I think that is a common theme we've been seeing with this. As our world gets smaller and smaller, the networking becomes more and more important. And you're not no man's an island. You're not on an island. If you get stuck, call a friend. Don't bang your head against the floor for 3 hours. Do it with somebody else, and you might learn something.
Now keep your phones close tomorrow morning then.
I'm busy.
I did want to bring up something we had a Q&A. We had a question, and it was going back to Tommy's presentation. They wanted to do the old GM trick, and I'm still upset about that GM class. Is checked 6 and 14 at that Mercedes for resistance, or check it for can. Why is that not a good idea?
What do you mean 6 and 14?
Pin 6 and 14 at the DLC.
Oh, with the breakout box.
So why or why not would that be a good thing?
Would that work?
Well, I don't want to answer that question. I want Keith to answer that question.
Eric is raising his hand.
I think we're all running to the same answer.
Yeah. All of us want to say it, but
DeFazio, why would that not be a good idea in that particular car?
You know, I'm actually answering this other question here too. I would actually like to have Eric answer this question. Can we let him get in there? Because I think that's why he's raising his hand.
Mm-hmm.
There he is.
He's there.
Eric, unmute. There we go.
Okay, I'm unmuted, right?
Yep.
Sure.
Right on. Because that's a diagnostic can, and it goes into the gateway and dead ends there. That's it. You're not going anywhere from there.
So will you get 60 ohms?
Yeah.
Because you need that for can to work, correct?
Yeah, high-speed can, yes. You will.
All right, so
Let me ask you, Eric, what if it was 67 ohms?
Oh, that'd be fine.
54.
Yeah, I'll go take that.
That's my number. By the way, if it's lower than 54, it's definitely broke.
Yeah. It's just enough.
Yeah, just enough.
So what you're basically saying is diagnostic can is basically a way for the scan tool to connect to the vehicle, and you're talking to what?
It's going to the gateway only. It's going to the gateway only, and so the gateway determines is the protocol that this scan tool is speaking able to get enhanced data, or are you going to just get OBD2? And then from there, like, okay, what do you want? Oh, I don't have that. I can give you this. You know, that's basically what's going down.
So keep in mind when you're using that breakout box on the OBD2 port, you're not accessing all networks. You know.
Not at all.
Right. So a lot of times questions get asked like that of why, and that's because, like you said, there's like 7 CAN networks on this car, right?
Yeah, different speed CAN networks. There's like a million CAN networks. Yeah.
So high speed CAN, there's no scan tool out there that can support more than 4. So if we don't have some kind of gateway to interpret all of that data and bus it, we can't talk to all the modules.
And high speed CAN can't talk directly to medium speed or low speed CAN.
Right. ISO 11898, which is the high speed CAN, I believe has a maximum of 30 possible modules per network. And when you start reaching that level, that's kind of a lot of stress. So, and let's not put the radio on the same network as the engine control module.
Yeah.
Let's keep mission critical separate, safety separate.
No, yeah, BMW found out that doesn't work so well. But they had to have PT CAN too, because there was no room for the engine control module and the transmission to work because all the other messaging that was happening.
The I believe what is the 1 megabyte a second is like the bus link, that 40 meters link, something like that. I don't remember exactly what the white paper spec is, but once you have that many modules on there sending that much info, you got to split it up.
You've got too many delays.
So think of it like a train station. All right.
Yeah.
Now there's an exception. There's an exception to the 16-pin connector. Land Rover.
Yeah.
Brilliant. They have their low speed CAN or medium speed CAN coming to the DLC. You can do a lot of stuff from the DLC. I was surprised.
Did I hear Land Rover and Brilliant in the same sentence?
Yeah, it
Well-
doesn't happen very often.
Or
Unless
newer
you're on the
Land
other
Rovers-
side. you
Newer
know?
Land Rovers are actually a much better than the other than the
Yeah,
last.
I was impressed. When we were covering for them, and I started looking at that. I'm like, wow, you can actually look at the body can right here. That's great.
They actually have service information, unlike some other companies.
What do you know?
I mean, I don't know what companies.
So again, the point to answer the question. I mean, we're killing a dead horse here, kicking a dead horse. But again, think of it like somebody was saying, the post office or the gateway. You still need on your scan tool to look at modules on different buses, but they speak at different speeds. You can't hook up directly, so you need some kind of interpreter, and that's what the gateway does. The gateway pulls all of the cans in, and then lets you talk to each individual module through a diagnosis. Yeah, exactly, like a router.
Yeah.
So that is the long explanation of why going to 6 and 14 really needs to come out of most CAN classes. Honestly.
Needs to
I
fix a
hope
lot
we-
of Chevy communication problems.
Yeah, I was gonna
Just
say maybe on some,
qualify
but
it.
not all.
Well, fine, but
We need
but
to add a step.
It needs to
to
be
an-
added to a CAN class.
We need to
because
add a
that is
step
ridiculous.
that says, look at your network design and then
There you go.
decide your process.
Yeah, and the
That
wiring
sounds like a
diagram will
great
tell you.
class for CarQuest.
Thank you. In our queue. Let me throw
Segue.
something else. Yeah.
Go to Randy.
Let me throw something else out here for a little discussion. It's kind of a hot button topic around shops all over the country right now. There's a lot of companies, of course, as you know, you plug a scan tool into that connector and you're really plugging it into a module. That's Ford and Toyota and obviously Chrysler and a lot of others. Chrysler is the only one that has turned the security features on for that. The rest of them are just a couple of lines of code away.
Best thing ever done.
What's your feeling about that?
I'm on the opposite. I think I'm the only one that says I think it was awesome.
You're right.
Yeah. So the obvious stance for the rest of the guys is that it blocked a lot of people from doing things without paying an additional fee or having a different tool. Got to understand the reasons for it. I mean, we may disagree on a lot of that, but it had to be done at some point, specifically for Chrysler, because of other vulnerabilities they had. That was their way to do it. And now we have legitimate paths. We have AutoAuth where you can use Autel tools, Snap-on tools, Bosch tools.
And frankly, I enjoy that they did that. That's a great thing.
The reason why I like it is there are less untrained, under-tooled technicians working on those cars now.
Exactly. That's what I was just going to say.
It's all about market share, right?
You have some people in chat that are agreeing with you there, Keith. But there is one other thing that we have to consider. We've seen all the press about cars being hacked, and a lot of guys just kind of blow it off. Oh well, it's just a thing in the paper. It'll never happen to me. But in fact, it does happen, and it's been thwarted several times just this year. So security issues with vehicles is a real thing. It's not just trying to keep the aftermarket technician away from that vehicle.
It's like a lot of people's gripe with the LSID program. I had someone give me a stat that came in, and I'll probably get in trouble for saying this because I don't know if I'm supposed to, but there were 600 car thefts last quarter. Not a single one of them was attributed to an LSID holder. They were all 6 of them that were attributed to like maybe a key getting in the wrong hands the wrong way, and they all came through dealers.
Yeah, dealers' control of keys is pretty
Very
lackluster.
loose.
Terrible.
Yeah.
So as much as it was a thorn in the side of a lot of people, it also, look at that. It wasn't us.
Well, it's all their sublet guys that that's their vulnerability. They have all the sublet guys that come in for the used cars to do the tint and the dents and the whatnot. So you've got all this traffic going in and out and in and out and into the wash. That's where the keys are the most vulnerable.
Having unfettered access to vehicles for long periods of time with no one paying attention to you.
Guys, thanks for everything tonight, everything you do, and for myself and all of our panelists, thanks for coming tonight. Stay safe out there, guys.
Have a good night.
Thanks, Randy.
Bye-bye, everyone.
Have a great evening, everybody.
Everybody. Be safe.
Good night.